Hello, everybody. We are here with Lara and Michael. And today we are talking about fine tuning large language models with Mosaic AI. So, Michael, why is this important? Why do we care about it?
Yeah, fine-tuning can basically teach the model something new, something that the model cannot do without that, or maybe we can, let's say, um, let the model focus on something. So I can maybe give you a couple of examples. So the general purpose models, they can do very different set of things. They can do pretty much everything, chat about very different topics, but they are very big. And because they're very big, they are also, they can be expensive, they can be a bit slow. So how can we use smaller models for our use cases? And of course, smaller models are not that smart. So that's exactly where fine-tuning comes into play. That's exactly where fine-tuning can help. Because with fine-tuning, we can refocus the small model towards some very, let's say, narrow use case. For example, if we would like our model to talk and to focus just on European financial regulation, we can, for example, get a lot of documents talking about that particular subject and use all that for fine-tuning. We could also use a lot of complicated questions that, for example, financial institutions are sending to the regulator and the answer that regulator gives. So I'm just kind of like giving an example. We could do the same about maybe a biomedical subject area, or I don't know, art or legal things, right?
Yeah,
And like,
we have a lot of customers that are very interested in the cost reduction side of things because like people have been, experimenting with LLMs for a while, and now when they start productionizing, they realize that there is a strong cost aspect when you serve like a really large LLM. So that's very interesting.
exactly. Just let me just add a couple of things just to sum it up. With the fine tuning, we can let the model learn a new task. And by the way, learn a new task, it's also something very useful if you need, for example, your LLM to extract a particular format, for example, XML, JSON, or something different. That's exactly where fine tuning definitely going to help. Or you can let your model learn a new domain, new language, maybe new programming language, which the model never seen, or new human language.
Nice. And so we have a lot of customers that are interested now in experimenting with fine tuning. The problem that we have often is they tell us, I don't have any data to start with. So what would be your suggestion then when people don't have data to fine tune on the model on?
Yeah, probably if they have no data at all, that would be really a problem. But in most cases, they do have some data. And by the way, if they have no data at all, they could like really use the team domain experts to create, I don't know, 10, 20, maybe up to 100 examples. And after that, what we could do, we could generate synthetic data. And that's a very powerful approach. So we could use this like very small data set created by human domain experts as kind of like as a seed, and we can generate similar questions. Or for example, if we have some text, for example, law, and we would like our assistant or our chatbot to be able to talk about this particular law, and we have maybe 100 to 100 questions, for example, specifically created by domain experts, or maybe those are the real questions coming from real customers. So then we could use, like do something very similar what we're doing with RAG. So use some context coming from the actual document together with the questions, and use all that to create new similar questions, or maybe completely new questions. And here we could utilize different approaches like chain of thoughts, and ask our very powerful language model to improve that question, maybe We could also instruct it to, let's say, answer it in a very specific way. For example, give some citations, give the references to actual articles in the law which are used to answer that question. Basically, really come up with a script which will make LLM generate the answers and the questions, of course, in a very specific way, which kind of resembles the domain, right? And another interesting point here, like the LLM which you're going to use for the creation of synthetic data, it's also something very important. Nowadays, right now, we have Llama 3.2, that's the current version, which like the big one, like by the licensing terms, cannot be used in the European Union in most cases, but 3.1 can be. And the big thing is that Llama 3.1 was the first generation of Llama models with like allowing generating synthetic data, and after that using the synthetic data for fine-tuning or training different models, of course, large language models as well. It was prohibited before with 3.0 or 2.0, but with 3.1 it's allowed, and we have a huge Llama 3.1 405B. It's a huge model which has similar quality to GPT-4 or maybe Claude 3.5 Sonnet. Like it's probably by metric, it's a little bit worse, but it's negligible. And of course, you can use that huge model to generate very good and very high quality synthetic data.
I had an interesting discussion with some startups yesterday, and they were saying exactly that on the synthetic data, that even if we want to create a fine-tuning data set and we crowdsource it to our business, etc., it's going to take us ages to collect something that is good enough or big
Well, now
enough
you
to do
can get,
a fine-tuning model.
yeah.
So then the synthetic data discussion came in, and they are discussing of implementing data set with synthetic data.
If I understand what you say, so you're saying we can basically start with just 200 examples, like a few hundred examples. I guess if you've been experimenting with a large model for a while, now that we have the payload logging tables, right, you can already have access to those few hundred examples, hopefully, which you need to curate, of course. So could you expand a bit more on how you would do that in Databricks exactly, like how you would, start this fine-tuning journey in Databricks?
Yeah, that's a great question. So yeah, if you already have your use case in production and you have it on Databricks, so probably also have inference tables feature activated. So it means that all the questions which users are asking are automatically logged in the inference table. So we have all that there. So the only thing we need to do now is to kind of filter out things we don't want to use. For example, things like are completely out of context and maybe some bad things. And after that, we can use all the questions we have to generate new questions. As we can just use them as a seed prompts, and we can ask an LLM to generate similar questions. And of course, we probably should add some questions coming from the domain experts, and all that together gives us a very good basis, very good starting point to generate, let's say, not a huge data set, but significant data set containing maybe a couple of thousand of questions and answers.
Okay, so then for kind of instruction fine-tuning or chat logs, we need a couple of thousands of examples. And then what about a more unsupervised fine-tuning?
So yeah, that's a very good question as well. In reality, if we have 500,000, we could try fine-tuning as well. And I would personally, I would try it out just to see how it works. Is it going to give a lift? Also to check if you have a signal there, right? But maybe my understanding is my my feeling for most of the use cases, if you're really dealing with something a little bit more complicated, and it's and we also would like to have to get a good quality, and there are a lot of specifics here. It would be better to have maybe around 5,000+. Also, we can say we can, for example, Dolly dataset has I think it's around 10,000 examples. And if you're already going to develop a script, I think it's going to be it's affordable and possible to generate a couple of thousands of examples. Maybe not tens of thousands, and of course not hundreds, but something around between 5 and 10K should be doable. And also coming back to the types of fine tuning. So yes, if we have a significant corpus, we can, before we are going to do the instruction fine tuning, we can just do continued pre-training. We can just use all that text and, for example, pick a base version of our foundational model and use it for the continued pre-training, right? And the recommendation would be probably if we have around more than billion tokens, it's let's say a good start. It's a good corpus.
Good pointer there.
The
Good
caveat
pointer there
here,
is
yes,
that sometimes we are thinking of the different fine-tuning techniques as in isolation, like either instruction fine-tuning or unsupervised fine-tuning. But actually, as you said, we usually find ourselves combining both. So first, yes.
of course, we should really use them together. And here is a caveat I wanted to talk about. If we kind of take this base model and do the continued pre-training on top of it, it means that everything that Meta, for example, did to get the instruct version, we are not going to use it. And in reality, they did a lot of great things. After they doing the instruction fine-tuning, of course, they aligned the model with the reinforcement learning, with human feedback, and maybe they did something else on top of that. So in reality, just pick an instruct version and do an instruction fine-tuning on top of it. I think it's a very good start. And by doing that, probably you're not going to lose all that nice things that the model has learned during the alignment phase as well. Of course, you can do the CPT on top of the instruct version, but by doing that, probably your model will forget some of the, let's say, instructions and alignment, some of those things anyway. So in reality, there is no right and wrong answer here. It's something that you would like to figure out yourself and just try out different approaches.
Excellent. And then if we are thinking of how we would do fine-tuning on Databricks, in Databricks we have a managed service. So why did we build this service? What is the purpose of this?
Yeah, so on Databricks, it's a fully managed service. You don't need to provision your own GPUs for that. So you can just do a function call, and as a result, after a couple of hours, you're going to, maybe even a couple of minutes, by the way, in some cases, you're going to get your model in the Unity catalog, already a fine-tuned version of the model, and you don't need for that to talk to a cloud provider and get your increase your quota to get the right type of GPUs. And I'm hearing it quite often, that's not easy. It's most of the regions are lacking big GPUs right now. And by using a managed service, you don't need to go through the whole hassle. And another big point is that we are using already, let's say, the hardware and software and everything together, which this whole system which works out of the box. We have a very reasonable starting hyperparameters. So basically, in most cases, which I have seen, the fine-tuning working out of the box, and you would get reasonable and decent version out of the box. Probably you would need to do like learning rate sweep, just try a couple of different values for the learning rate. But other than that, it's kind of okay. It should be okay, right?
Amazing. And then can we summarize very quickly before we go through the demo? What are the things to watch out for when you do a fine-tuning job? Like your quick tips, just yeah.
Yeah, probably first you should make sure that you have the high quality data. You should really have like the nice data, and make sure, for example, that you have I don't know, at least 1,000 examples. That you also have the right format. If you are using chat completion format on Databricks, you don't need to do any formatting yourself. You just, I'll talk about that during the demo a little bit, but you just provide the right format from the very beginning. I mean, like the chat messages, and that's all. If you are doing the instruction fine-tuning, in that case, you would need to format everything yourself. You would need to apply the prompt template, and it's different for different versions of the model. So there are basically it's possible, but it's a little bit more tricky, right? With chat compilation, you don't need to do it; we will do it for you. And after that, you should set the right learning rate. Maybe use like a reasonable default, and probably that's all. If after the fine-tuning, for example, your model generates something extremely weird, probably your learning rate might have been a bit too high, so you might want to reduce it. And I think in general, it's a good approach to try a couple of, let's say, a couple of other versions, so you can like go order of magnitude up and down. What else? That's pretty much it, I believe. It's really easy. You don't need to kind of provision anything. You don't need to fix and install complicated packages, and I don't know, set up 1,000 hyperparameters. All that is already kind of taken care of.
Great. Should we jump into the demo?
Since we have already started talking about building an assistant for the like regulatory compliance for the financial industry, so that's it's actually a topic of our demo. So here we will fine-tune a model. We'll fine-tune Llama 3.1 and improve its capabilities around answering questions about capital requirements regulation. So it's a law in European Union which all the financial institutions have to use. And what we are going to do, at first, we will generate a couple of thousands of questions. So we will generate synthetic data. And after that, we will use the synthetic data to fine-tune our model. And after that, we will compare the model performance using LLM as a judge approach. So we will compare the vanilla model without fine-tuning with the version which we have fine-tuned. Maybe get started. So we can start with this first data preparation notebook. And at first I will like install simple dependencies and do some very simple stuff. And after that, I'm going to load and clean my data. So I have uploaded a bunch of PDF files into the UC volume. And now we are going to ingest all those PDF files to the Delta table. And after that, of course, we will chunk them and generate the questions for each chunk. Okay, so let's now maybe look into this method a little bit so that you see what's happening inside. So load and clean data, it gets the source folder, and after that we are using binary file format in Spark to read all PDF files, and after that we have a UDF which uses a PDF reader to parse each PDF file. And as you can see, so here is the UDF, and we are just applying this function for each batch, or sorry, for each row.
Cool. And the chunking here is just kind of aggressive, so we just chunk on specific number of tokens.
Let's now go into the chunking. So here we have a next method which called split, which is going to chunk our documents. And here so here is the split method as well. So in reality, we are using here recursive character text splitter, which is also uses our tokenizer. So it will try to chunk text into chunks of 500 tokens. So if we go back here, you see that we are specifying the chunks 500. Probably in the, let's say, real scenario, it would be better to have a chunking strategy which really chunks text using, for example, each article comes into own chunk. But I have not implemented this here. I have just used something standard coming from, I believe it's Langchain. I don't even remember. Yeah, it's coming from Langchain. And it's also UDF, which we can automatically use Spark to apply to each row. Okay, so now here you can see that the result. So here we have our chunks. And we put all that into a Delta table. So it's going to be called splitted documents. And now we can go to a second notebook. And here we are going to generate our questions. And for that, we will have a bunch of different prompts. So at first we'll go over the prompts, and after that we can look into the code which is going to execute those prompts. So the logic how I'm generating questions and answers is the following. So at first, I'm asking an LLM to generate first question for the given chunk or given context text. After that, I'm asking an LLM to generate something like a judgment for the generated question. So judgment is I'm asking an LLM to generate some thoughts and reasoning about this question, and also to generate a judgment if it's a good question, if this question can be improved somehow. Just like I'm just making an LLM to think a little bit about the question. And after that, after we have our question and we have the judgment, I'm asking an LLM to improve the question according to this judgment. And in a real, more realistic case, in this judgment, you can add all the criteria you have. For example, if you want the question to cover certain topics, you can also add this to this judgment, judgment prompt, and you can maybe even have multiple judgments calls to validate that the question, for example, covers the topics you need or meets the actual criteria. And here, we are asking our model to improve it. I can also later show you what it exactly does, and it's actually doing quite interesting things here. And then we have exactly the same.
This is the same LLM that will generate the question and then evaluate how good the question is, or do you ask different LLMs?
So it's configurable. You can use different LLMs. I'm using the same LLM for question generation and for judgment, but of course you can use different. So probably the idea is that we should be using here a very powerful LLM, and for example, we can fine-tune a very small LLM. Like here we could use Llama 70B, and we can fine-tune Llama 8B.
Got it.
And for answering, we have the same logic. So first we asking an LLM to generate an answer. Like here, we have context, questions, and answer. After that, we are asking an LLM to provide a judgment on this answer, if it's a good answer or not. And after that, we are asking an LLM, sorry, it was here, we have context, question, answer, and we are asking it to provide judgment. And after that, we are asking an LLM to improve the answer.
Based
And
on the
we have,
judgment as before.
yes, of course. Based on the judgment, we would like to improve the answer. And now we have a method or function build instruction eval dataset. And here we are providing all our prompts and the chunks and the LLM. And as I said, we are using Llama 70B here. And here you can see a couple of questions that it has generated. So, for example, here is the chunk, and here is the initial question. What is the minimum frequency at which the variational margin must be calculated in order the financial institutes to recognize? Okay, so some actually nice question. And then we see that there are some thoughts, and also there are some criteria or some points that LLM has avoided.
Oh, this is where you said before that you can actually add your own criteria and yeah, amazing. Okay, cool.
So that's the judgment
Yes.
generated by an LLM. And here is the question which was improved. And as we see, it has not changed a lot, but I think the reference to an article was not there. Look, see, it hasn't referenced an article. And we see in context, it was actually asking about this article. So in the improved question, now we have this reference to an article.
Very cool.
And in here, as you see, here is an answer. Initial answer, the rational margin must be calculated and changed at least daily. Right? It's very brief. Probably it's correct, but it's very, very brief. If you just get it, that answer, you don't know what it kind of refers to and everything. And here we can see that it says it's good.
Against specific criteria again. Like why it marked it as good.
Yeah, but look, it says there is no additional information needed to fully answer the question, right? So it says that it's kind of too brief. And now let's see how the improved version looks like. It has like added a little bit. But of course, in the actual prompts, we could add it like, please add citations, add reference to the articles, and we could be very explicit about what we wanted to do. And okay, so in interest of time, maybe now let's very briefly look on the fine-tuning itself.
You don't need an army of SMEs to write those questions, right? And here you really try to improve on them. And probably I imagine now would be a good time to have a few SMEs review all those questions and provide initial thoughts. But most of the work has been done, basically, hopefully.
Yeah. It's always a good idea to ask an SME to come up with an examples first, which I have not done here. By the way, if we have somebody who is listening that and interested, like working in this area and would like to provide examples in this particular area, I would be really happy to get those like actual questions and answers just to improve it. But yeah, so probably it makes sense to ask SMEs first to come up with some examples, maybe 10, 20, or maybe 2 examples per kind of topic domain. And after that, we can generate the synthetic data. And after that, we can maybe iterate it with SMEs a couple of times. So let them tell if the questions and answers are good. And I think after that, we can do the fine tuning. And that's how you can do the fine tuning on Databricks. As I said, it's just one function call, right? I have not shown, by the way, how we generate this chat completion format, but it's available in this Git repository, which we're going to share with you. So feel free to go and see how it really looks like. So that's how we run the fine tuning. And after that, it's like the name of the run, and we can see what happens with the run after we have like kicked off the process. And we can,
just to say here that the fine-tuning process is completely managed, right? So apart from your command you just wrote there are and the parameters you configured, this is it. We take it then and we execute it for whoever is running the job.
Yeah, exactly. You just run it, and then you don't need to think about it. At some point, you just get the result. And okay, that was one completed. I was lucky. So as you see, we have now a registered model. In the UC, and here we have the loss, train loss, validation loss, also learning rate, everything. And we have event log, and of course you can go into the model metrics and you can see, for example, how the loss has evolved.
Cool.
It looks like the data set was not that big for this particular one. Probably I was not that lucky, but still you can see how it like looks like. And as you see, it's like just taken 15 minutes, so probably it was maybe a tiny data set. And last very important piece, how I have after that evaluated it. So we have an evaluation notebook. And for that, at first we are, of course, building the Langchain chain for that. And we are loading our questions and answers. And after that, we have a method which generates an answer using the provided chain. And after that, uses some models, in our case, Llama 70B.
Okay, now in that chain, we mainly have our fine-tuned model, and then the judge model is the 70B instruct.
Yes, so that's going to be our judge model, and that's the chain which is using the fine-tuned version of the
Excellent,
model.
yeah.
And here, that's basically my MLflow experiment where I have run all that with multiple versions of the models, multiple ways. And here, that's just what I wanted to show, that our vanilla model, so our fine-tuned version is a little bit better. And the variance is also, with the fine-tuned version, is a little bit smaller. So basically, we can kind of get a nice lift.
Nice.
Without even providing some like real SME insights.
Beautiful.
Okay, any other questions?
Cool. So, in general, then, have you seen from experience, like how small or big should then a fine tuning job be, right? So around 1,000 examples, we say it's fine. So we would generate 1,000 plus synthetic examples in this case, or we would start with 1,000, then see fine tune, then do a little bit more fine tune.
To be honest, I would start with maybe 1,000 manual examples coming from the SMEs, and then I would generate between 5 and 10,000 examples, because if you're going to generate 1,000, it's not going to be like a very big difference for the company. Like, look, now we are talking here about financial institutions who need to report according to CRR. So usually for those companies, I think generating 1,000 or 5,000 or 10,000 examples is not going to make a very big difference. So, and after that, of course, before that, we should make sure that we are generating good data. So maybe we could start, of course, with maybe also 100 or 200, validate it a couple of times, and after that, we generate 10,000 or 5,000, and then just do the fine tuning and see how it goes. And yes, if you really would like to be sure, we can start with 1,000, of course. But I'm almost convinced that with 10,000 and with maybe even more, we would have a better quality.
Okay. And last question from my side is, when you define how your synthetic data you want to look like, usually we want our data for fine tuning to be covering different aspects of our problem, right? So that we have a good coverage. How do you define that in the prompt? So how do you make sure that, let's say, you have different kind of questions covering different aspects of your problem?
Yeah, so that's exactly where prompt engineering is important, and that's probably where AI engineers can work together with the domain experts to formulate what exactly we want, like how exactly our questions and answers should look like. But at the end of the day, it's something we just formulate in a simple language.
So everything will happen in the prompt.
Yeah, I think most important things are going to happen in the prompt. In a little bit more complicated situation, we might have multiple prompts. Like here we have 3. Maybe in a very complicated situation, we would have 10. But still, it's going to be pretty similar logic.
Amazing. Thank you, Michael.
Thanks for having me.
We will share the repo and in the description.
Yeah, and also we have a few videos
Awesome.
on how to show how to use fine-tuning using the UI, how to use the review app also when you want to have business stakeholders, evaluating what you're doing, etc. So you can always check that out. Thank you.